Tuesday, October 18th, piecewise functions lesson. Okay. All right. So if x is less than -2, then f of x equals x squared minus 1. If x is greater than or equal to -2, then f of x equals 5x plus 3. Okay. So the function, what it is, just changes depending on where we are on the coordinate axes. Does that make any sense? Okay. So first, let's practice plugging values into f of x. Okay. So f of -5, f of -5 is going to equal what? What do we have to do here? Is -5, first we have to check to see if our -5, is it less than -2 or greater than or equal to -2? Right? -5 is less than -2, so we have to use this top f of x right here. So f of -5 is going to equal to -5 squared minus 1, which equals 25, minus 1, which equals 24. Right? But for f of -2, right, if our x is equal to -2, then f of -2, right? -2, is that going to be less than -2 or greater than or equal to -2? Yeah, it's going to be in the greater than or equal to -2 range, so we got to use the bottom f of x when we plug into x equals -2. So this is going to be 5 times -2 plus 3, which equals -10 plus 3, which equals -7. All right. And then if we plug in f of 7,
teachers, please excuse the interruption. Dr. Joby will be offering mass in the chapel in just 2 short minutes. Available? Please come.
All right, we have f of 7, right? Since 7 is greater than or equal to -2, we plug it into this bottom of x right here. So f of 7 is 5 times 7 plus 3, which equals 35 plus 3, which equals 38. Okay, we having trouble understanding that or no? Okay. So it's like a regular function, but it just changes depending on where we are. Okay. Let's go to g of x. G of x. Okay. So we'll zoom out a little bit so you guys can see the last examples. G of 2. So g of 2, right? Let's think about this. Right. We have 3 domains. X is less than or equal to -4. X is between -4 and 1, and x is greater than or equal to 1. Am I going to do plug it into the first line, the second line, or the third line? X equals 2. The third, right? 2 falls into the greater than or equal to 1 category, right? So I'm going to plug it into the third line. So g of 2 is going to be equal to 2 times 2 cubed plus 9, which equals 2 times 2 times 8 plus 9, which equals 16 plus 9, which equals 20. 25. 25. Okay. Feeling okay about that one? When x equals -1, if I plug in x equals -1, which line do I use? First, second, or third? Second, right? Because -1 falls into the greater than -4 but less than 1 category. So I'm going to do g of -1 equals -1 minus 1. -1 is positive 1. 1 minus 1 is 0. Are we feeling okay about that one? Just want to make sure we're understanding this topic. And then g of -6. G of -6, I plug it into which line? The top one, right? Because -6 falls into the category of x is less than or equal to -4. So I'm going to do 1/2 times -6 plus 3, or -3 plus 3, or 0. Fun. Okay. All right. Good stuff. Piecewise, very important topic. Very important topic in many different areas of mathematics. Okay. A lot of piecewise functions in physics. We okay if I move on? Not going too fast? All right, now I'm going to show you guys how to graph a piecewise function. Okay, this is kind of tough. My pre-calc kids really struggled with this. So I'm going to show you guys how to graph this, okay? So first thing I'm going to do, my first step when you're graphing a piecewise function is draw vertical lines at domain boundaries, I'll say. You probably don't understand that. That's going to be, so I'll start to show an example. If we look at the ifs, right, the x if and the negative 2x plus 1 if, right, our only domain boundary here is negative 3. You see that, how like the graph changes? Okay, draw vertical lines where the graph changes, that's what I should say. Draw vertical lines where the graph changes. The graph changes here where? At x equals negative 3. So I'm going to draw a vertical line there. I'm going to do a dashed line. Or let's do like this one, this color. So x equals negative 3. Let me draw a vertical line through that. The first step. Okay. Second step is going to be graph. It's going to be graph the top equation to the left of that line. Okay, and then I'm going to erase, so here, one way I like to do it, okay, so here's what I'm going to do. I'm going to highlight that top line in pink, okay, and that top line, right, f of x equals x, if x is to the less than or equal to negative 3, or in other words, if we're to the left of this line, f of x equals x, okay, so that's what that's saying. So let's graph that, okay. So one way I like to do this, I taught my seniors, okay? I'm going to graph the function f of x equals x, right? That's just this line. What you can do is you can graph the whole thing, right? But we only want to keep the pink line in this region here. Right, in this pink border region here. So what we can do is you can graph the whole thing and then just do a partial erase and erase anything to the right. Does that make any sense? Okay. And then, okay, notice too that pink shaded line, there's an x is less than or equal to negative 3 because there's an or equal to, where right here where my graph meets that line, that vertical line, it's going to get a solid pink dot there. So think like what we did for interval notation. Right, less than or greater than or equal to, the or equal to symbols get solid dots on the boundary. Without the or equal to underlines, they get hollow dots, hollow circles on the boundary. So then what I'm going to do here is I'm going to highlight that bottom f of x in blue. Okay. And so what we're going to do is, what you can do is you can graph negative 2x plus 1, graph the whole thing. You can do that. So I'm going to do that, negative 2x, so that's this, right? And then what I can do, right, but I only want to keep that line in this blue outline region here, right? Because the function is only equal to that line when we're to the right of x equals negative 3. So what I'm going to do is I'm going to take my eraser and do a partial erase of everything to the left. Okay? And then notice on the line, since it's x is just greater than -3, I'm going to need a hollow circle here. And that's it. I'm done graphing now. Did we follow that?
So it's basically like a split.
Split, yeah. And then, right, what that hollow circle and the solid line tell us is like the reader, the person looking at this graph is going to know, okay, to the left of here, the function's equal to this line. To the right, it's going to be equal to this line. But what about right on this vertical boundary here? What this is saying, telling the reader, is on the vertical boundary, the function's equal to the solid dot, not the hollow circle. Does that make any sense? So it's still a function. Okay? So what's the domain here going to be? What's my domain going to be? In interval notation. What's the farthest to the left my x goes? What's that? Yeah, negative infinity. Right, and then what's the farthest to the right it goes? It's going to be positive infinity, and then I don't skip any, there's no x's in the middle that I skip. I cover every, right, for every, right, it goes from left to right. It jumps right here, right, but we still have a point where x equals -3 right here. Okay, what's my range going to be? What's my range? What's the lowest that y goes? What's the farthest down my graph goes? What do both these lines do? They both go to negative infinity, right? And then what's the highest my graph goes? Not positive infinity. See here, look what's going on here, right? So this pink line, right, it starts going up and it stops right here, right? And this blue line, right, it's going up, but it stops right here. So the highest it gets, it's going to be, what is that, 7? Yeah, +7. That +7, since I have a hollow circle here, that +7 needs to have a parenthesis. Okay? The hollow circle means that +7 is not part of the graph. The graph just gets really close to +7.
But -3 doesn't matter at all?
-3 does not matter for that. Because you're looking at the whole piecewise function. You're looking at both sides.
Wait, so why is it negative?
And not positive infinity, or what?
Or why is it not like? Why is the 7 there, but the other lines?
Yeah, so if you look at these arrows here, both these lines have arrows pointing down forever. Neither of them have arrows pointing up forever, right? There's no arrows pointing up forever. Right? It's just this blue line gets as high as y equals 7, and it stops. Okay, yeah.
I'm confused on how line is graphed. I thought is it not graphed like a -3 y intercept?
-3 y intercept.
What? The blue line is graphed with a -2x plus 1.
Yeah.
But then, why is the pink one graphed?
The pink one stops at this vertical boundary here because the piecewise function tells me that f of x only equals the pink line if x is less than or equal to -3. So at the line, at the vertical boundary where x equals -3, this pink line has to stop. If that makes any sense. Does that make any sense?
Well, no, I didn't see the x here to the left. So
Oh, okay. Yeah, no worries. Okay, so that's our first example. Okay, we can try more. You guys okay if we see another example? All right. So again, my first steps, and then my third. So my third step was graph bottom equation to right of that line. To the right of my vertical boundary. Let's get through this example and go to lunch, okay? Let's get through this real quick, okay? So if we do the top equation, let's highlight that in pink. We'll highlight the bottom in blue. Okay, where is my vertical boundary going to be? At x equals what? -1, yeah. So we'll do this in black this time. Hopefully that'll work better. Yeah, so let's do a vertical line through x equals -1. Okay. Okay. We're going to graph the top function to the left. Okay. And we're going to graph that bottom function to the right of that line. Okay. So now let's graph that top line. The top line is negative 3x minus 7. So what I'm going to do is I'm going to graph the whole negative 3x minus 7. So my x-intercept is negative 7. My slope is negative 3. So I'm going to graph that whole line. Okay. And I'm going to erase, right? I don't want to have the pink line in my blue region, so I'm going to erase where the pink line's in the blue region. Okay. And then that pink line, right? It has x is less than negative 1, so on the boundary I'm going to put a hollow circle. Just like that, okay? And then to the right of that line, now I'm going to graph x equals negative 5, f of x equals negative 5, so that's just a horizontal line right here, right? And then I don't want any of that blue line to be in my pink region, so I'm going to erase to the left. Okay. And then since that has negative 5, if x is greater than or equal to negative 1, I'm going to put a solid dot there. Okay. So then my domain here is going to be all reals. Right? My pink line has an arrow that points to the left forever. Right? My blue line has an arrow that points to the right forever, and then I don't skip any x values in between, okay? Okay, and my range is going to be what? Range is a little tough. What's the lowest lowest y value I can find on this graph? Negative 5, right? And that's included, so I'm going to do a bracket with negative 5. Okay. Then what happens is it skips up, right? It skips from y equals negative 5 to y equals 4. And that 4 gets a parenthesis since it has a hollow circle. And it goes up to positive infinity. So it ends up being, this is going to be confusing, but I have a bunch of points where y equals just 5, and then I skip up to 4, and I go from 4 to infinity. So that's why that's the range. Does that make any sense? Yeah, good work. Go to lunch, come back at 12:45. Can I pause this at all? You know how to pause recording or no? What if I can?
Why wouldn't it be just 5 to infinity?
What's that?
Why wouldn't it just be 5 to infinity for the range?
It skips from 5 to 4, right? There's a jump here
But we didn't do that for the previous one.
because there was no jump. There was no jump.
Oh!
Yeah, it jumps. Yeah, now we're doing big kid math now. I don't know how to pause this. I'm just going to run it and upload a really long YouTube video.
Delete it after just delete that middle part.
That's too much work.
After the video. So you're just gonna upload a.
This thing's hard drive is ridiculous. What's that?
So you're just gonna. Oh, so because the lines didn't line up at the exact same point, it jumps.
Yeah, exactly. That's a good way of phrasing it.
Because I was like, I don't know, because I didn't understand up until you were like, oh, because of here. But so if the lines line up at the exact same point, technically,
Yes. Yeah.
it doesn't jump.
Yeah.
But otherwise it jumps.
Well, jump is continuity. I'm introduced to the world of big kid math.
The world of math that makes you want to pull your hair out, the reason why you get out.
Yeah. Do you have a math league?
Not good. I thought. straight from the homework.
Oh, gotta finish these notes. All right, jump right back into this.
Is that always?
Oh, 12:45 will start. Yeah. Now you put your lanyard on, please. Thank you. Sheldon, put your lanyard on, please. These kids trying to take their lanyards off.
Why are you wearing lanyard backwards?
Get out of the way, man. You gotta get out of the way.
But doesn't that choke your head?
I like this feeling a lot better than this. You know how I'm trying to like help you like this? All right, let's go back right into this number 5. Number 5, right? First step. We're going to draw a vertical line where the graph changes. So where does the graph change here? Yeah, x equals 2. So let's draw a vertical line there. I'm going to try yellow this time. I feel like yellow will pop out. There we go. Can we see that or no? Pretty good. So we draw a vertical boundary here. It changes at x equals 2. Okay. And then I'm going to highlight this top equation, this top f of x in pink. I'll highlight the bottom function in blue. Okay. So to the right of our boundary line there, we're going to want the blue function. All right. To the left of our boundary line there, we're going to want the pink function. Okay. Right? Because g of x equals the pink function when x is less than 2, or to the left of my yellow boundary line. Or it equals x plus 2 when we're to the right of our yellow boundary. Okay. So let's go ahead and graph that top function, negative 5 halves x minus 1. Okay, so my y-intercept is negative 1, and then what's it, rise over run, so it's going to go down 5, and to the right 2. Yeah, okay. So that's that first line, okay? Right, and then again, guys, right, I don't want to have my pink line, I don't want to have any portion of my pink line in my blue region. So I'm going to go ahead and erase that. Oh no. Okay. So I erased everything, all the pink line that was in the blue region. I only want the pink line to be in the pink region, okay? And then on the boundary there, am I going to put a hollow circle or a solid dot? Hollow circle, right? Because x is only less than 2, only when x is less than 2. I'm going to put a hollow dot there, a hollow circle. Okay, hollow circle, okay? And then switch over to blue. Okay. X plus 2, okay, so I'm going to go to the y-intercept is positive 2, slope is 1. Okay. Right, and then I'm going to erase any part of this blue line that's in the pink region, because I only want the blue line to be in the blue region, okay? We following this so far? So I'm going to erase that. And then on that yellow boundary, is my graph going to get a solid dot or a hollow circle? Hollow, right? Because it says x greater, or just greater than 2. So there we go. How are we feeling about graphing these? Do we like the way I'm graphing them? Okay, good, good. Okay, so my domain now, my domain. Domain, right? So what's the farthest left my x goes? This pink arrow here, right? This pink arrow here, right, points to the left forever, right? So infinity's domain's going to start at negative infinity. What am I going to write after negative infinity? Dang. Yeah, so he's catching on. He's catching on. Yeah. So here's what's going on, right? So the farthest to the left that this graph goes, right, there's an arrow that points to the left forever. So it goes to negative infinity. There's also an arrow that points to the right forever. So it goes to positive infinity as well. So you might think, okay, the domain's negative infinity to positive infinity. That's close, right? But look what's going on here. What do we notice about the yellow boundary? What do we notice about the yellow boundary? Both of them have hollow circles there, right? Right? What does my function say? What does g of x equal when x equals to? Does it say what it equals when x equals to? It doesn't, right? It's undefined, right? Our function g of x is not defined when x equals 2, so we got to pull that out of the domain. So it's going to be negative infinity to 2, union 2, positive infinity. You guys remember that? Does that make any sense? Okay. All right. Then my range, what's my range going to be?
Would that be -6 to power of 3?
Yeah, it'd be -6 with a parenthesis, right? This is a hollow circle, so we do a parenthesis. It's going to be -6 is the lowest my graph goes, and then there's two arrows pointing up forever, so it goes all the way to positive infinity. Okay. Feeling all right about that? Okay, so give us a few seconds to catch up. We can move on to 6. Okay, let's move on to 6. Look what we got now. We got 3 lines. We got 3 lines on here, okay? So what are the boundaries? What are the boundary lines where x changes, where the function changes? What's that going to be? Where does the function change? Are we having trouble seeing this? We're just not. So -5 it changes. It changes at +1. Okay, so we got to draw on both of these. So I'm going to draw the yellow line at x equals -5. And then I'll do an orange line, x equals +1. I'll label these. So this is x equals -5 is this line. This is the line x equals 1. Okay, so there are my 2 boundaries, right? So my first step was the same. I just had to draw 2 vertical boundaries now. Okay, and I'm going to go ahead and highlight my 3 functions. So g of x equals -1 if x is less than or equal to -5. Okay, equals -x minus 3 if x is between -5 and 1. I'll use green, and then it equals 6 if x is greater than or equal to 1. Okay. Okay. So let's graph that pink, right? So let's look at this. So to the left, right, we're going to want to graph the pink function everywhere to the left of x equals negative 5, okay? So I'm going to highlight top and bottom there in pink. Okay. I'm going to want to graph the blue function everywhere x is between negative 5 and 1. Okay, so I'm going to highlight the top and bottom in that region with blue. And then I want to graph the bottom function everywhere where x is greater than or equal to 1, or everywhere to the right of the x equals 1 boundary. So I'm going to highlight the top and bottom in that region with green. Okay, are we feeling okay about that? Okay, and then let's go ahead and graph, okay? So let's graph the line g of x equals negative 1. That's just a horizontal line through negative 1. Oh, right, and again, right, we only want our pink line to be in the pink region, so we're just going to go ahead and erase everywhere. Erase the pink line. We're going to erase the pink line everywhere it's outside the pink region. And then right here on the boundary line is my pink. It's my pink function. Is it going to get a solid dot or a hollow circle, and why? Solid dot, right? Because x is less than or equal to negative 5. So it's going to get a solid dot. Okay. Now we're perfectionist. Yep, and then I'm going to graph my blue function in the middle. I'm going to graph it everywhere, then erase anywhere it's outside the blue region. So g of x equals negative x minus 3. That's going to be my y-intercepts right here, and then it has a slope of negative 1. There we go. Right, and then again, we only want to keep part of our blue line in the blue region, so we'll erase it anywhere where it goes outside the blue region. Okay, and then we gotta mark our boundaries, okay? This blue function on this yellow boundary, is it going to get a hollow circle there or a solid dot? Hollow, right? Because it's negative 5 is less than, just less than x. It's going to hollow circle. And then on that orange boundary, is it going to get a hollow circle or a solid dot? Hollow circle, yep, just for the exact same reason, okay? All right. And then we'll go ahead and graph this green line everywhere g of x equals positive 6. But we only want to keep the part of the green line that's in the green region. So we'll go ahead and erase the green line anywhere it's outside the green region. Okay. And then on that orange boundary, is my green line, is it a solid dot or a hollow circle? Solid dot. Yep, good job. Awesome. That's it. So it takes a little bit, but I think we're understanding it, hopefully. Okay, that's how we graph piecewise. Okay, so what's my domain going to be here? Chris, can you take the AirPod out, please? What's my domain going to be? So we have an arrow pointing to the left forever, so we're going to have negative infinity. And we have an arrow pointing to the right for every sort of a positive infinity. So it's going to be negative infinity to positive infinity, but do we skip any? Do we skip any x's in the middle? We don't, okay? And that's because, like right before this example right here, both of these were hollow circles that are one boundary. At both of our boundaries here, we have at least one of our functions that has a solid dot. Has a solid dot on the boundary, so we don't end up skipping any x's. Does that make any sense? Okay. Okay, then what's my range? Boy, this is a fun one for the range.
Is it 3 separate?
It's not going to be 3 separate. So what's the lowest y we have? The lowest y is -4, right? That's going to be with a parenthesis because it has a hollow circle there.
Yeah.
And then it goes up to +2, right?
Yep.
And then it skips, right? It skips from +2 to, what is that, 6 or 7? 6. So we got to put a union and then 6. It actually doesn't go above 6. So we're going to put a squiggly, 6 in it with a squiggly. Right? So it goes from -4, and so we basically end up ignoring the pink line for the range. Up to +2, right? Both of these get parentheses since they have hollow circles. And then we skip up to 6, and then it's just 6. So anytime we have an interval with one number in it, we just put just that one number and put it in squigglies. What's that? For the pink line, so the range of the pink line is -1, right? But -1 is included in this interval anyway, so we don't need to, like, yeah. We feeling okay about this? So that's number 6. Okay. Good, this is going pretty well, I think. Good. Okay. Number 7. Mrs. Hollis told me to go ahead and let's switch to the homework. There's a couple homework problems that I don't think are covered in the notes super well. So let's work on those. So we go to homework assignments, piecewise homework. Ability. Piecewise functions. Okay, so let's go to the piecewise homework. Okay, I'm looking at the homework. And I'm looking all the way down to 12 and 13. 12 and 13. Okay, on the homework. And it's going to be on the back side of the homework at the bottom. Okay. And it says write a piecewise function for each function graph below. Alright, so let's try this. Okay. So, first of all, if we write f of x equals, okay, first step. And then how many lines is my piecewise function going to have for 12? 2, right? Because there's 2 different functions. So the first one, right? Then let's write if and if. Right? What should I write after the first if here? What should I write after the first if? What's the region for that first function? If x is less than or equal to 0. Why did I write x is less than or equal to 0? Because I have a solid dot right there, yeah? Yeah. And then what is that line there? It's going to be, has its a line with slope-intercept form. It has a y-intercept of +2, and the slope is up to over 6, so 1/3. It's going to be 1/3 x plus 2. Okay, what's my if for the second function? What's my if for the second function? Plus 2. Yeah, it's greater than 0. Why does it not get greater than or equal to? It's a hollow circle. Yeah, exactly. Okay. And then what is this line? It has a y-intercept of -5 and a slope of 1, so x minus 5. How do we feel about that one? Feel okay? Then for 13, let's do 13, okay? F of x. How many lines does this piecewise have? Yeah, it has 3, right? Because there's 3 functions here. A line with a negative slope, a line with 0 slope, and another line with negative slope. So let's make it a bit bigger. All right, write my 3 ifs. What should my first if be? If x is what? Yeah, what about which one? Which equality symbol? To the left of -1, right? With a hollow circle. So if x is less than -1, okay? And what is that function? Let's look at what it is, okay? You might need to extrapolate a little bit to get your y-intercept. So if this kept going, it'd come down to here. This line, so it has a y-intercept of -2 and a slope of -1. So it'll be minus x minus 2. See that? X minus 2. Are we following that, what I'm doing? And then for that second one, right? For that second one, what do I write? X what? What's that? Yeah, so greater than -1, right? So the right of -1, so if it's greater than -1, and then what? What else do I need to write? Yeah, it gets cut off at x equals 3, and that's with a hollow circle at both places. So if x is between -1 and 3, and then that function, what function is that? F of x equals 4. Yep, it's a constant function. And then that last boundary. What's my last boundary? If x what? Yeah. And it's greater than or equal to, right? Because we have a solid dot there. Okay. So hopefully you should be noticing a pattern in this course, right? Greater than or, right? Or equal to's go with solid dots, go with brackets, right? Parentheses go with just less than or just greater than, which go with parentheses, which go with hollow circles. Okay? And then we gotta look at what function this is, right? It's gonna be a line. We gotta extrapolate a little bit to see what the y-intercept is. Looks like the y-intercept is, what is that? 1, 2, 3, 4, oh wait, yeah, 5, right? Positive 5. So -x plus 5. You can also do point slope. So we could have said, okay, let me just like, what point is this right here? This is 3, -1. The slope is -2. Then you can use point slope to figure out what the equation of the line is. But you need to convert to slope-intercept form though to put it in your piecewise.
But would it be -2x plus 5?
Oh yeah, sorry, yeah, it is -2x. Thank you. Sorry. Thank you. -2x. Right? How do we feel about that? Feel okay? So you'll do 14 on your own for homework. Okay. And then let's keep working on the homework a bit. Can we all try like number 11 together? Let's all try number 11 together. So go ahead, take a couple minutes, see if you can work on it. All right. minutes, and then I'll just start filling it out on my own without explaining, and hopefully it'll match yours. So yeah, I don't know if some of you might be not a bad idea to buy highlighters for this class. Honestly, I don't know if you want. If you want, you don't need to, but kind of helpful. You can start doing more stuff on your iPad. Okay. Another minute or so, and I'll start doing it. Boundary lines. Alright, so that's what your graph should look like, and then the domain is going to be, it's all reals except it's going to skip. It's going to go from negative infinity. It's going to skip -1.
Does it just skip -1?
Yeah. And then the range will be negative infinity. It's going to 3. It's going to skip up to 5, and that's just 5. Okay, so do this homework for next Wednesday. Are we feeling okay about this? Good. Hey, great work today, guys. Good. Yeah, that was it. Here, let me stop recording.
Are you coming to research this?